Hi, Assalamualaikum and have a very nice day. First of all, I would like to thank to my supervisor, Nur Bahira binti Nordin, for guide me to complete my project. I am for Faculty of Electrical and Electronic Engineering Technology and my name is Muhammad Farhan Azir bin Mazman and my matric number is B081810066. And I would like to present my bachelor degree project 1 entitled Flood Detection based on IoT. Okay, the outline content of my project presentation is first introduction, problem statement, objective, scope of project, lecture review, methodology, preliminary result, and lastly conclusion. Okay, first of all, for my introduction, as we know, in Malaysia, flooding is a natural disaster that occurs every year. A flood occurs when a water overflows terrain which usually dry. Next, there are several kinds of floods such as river flood, urban flood, flash floods, and alluvial floods. So, the project is designed to monitor a system for river that use local sensing data via microcontroller system for monitoring, and the system also can measure the various flood parameters such as temperature, water level, and water velocity. Okay, next for the problem statement of this project is first, the majority of the flood victims are not fully aware of the upcoming flood calamity because does not have a flood metering and warning system. Furthermore, the victim is lack of information. For example, majority of the flood victims are not fully aware of the upcoming flood calamity because does not have a flood monitoring and warning system. In certain situations, the authority has a warning to the victims, but due to the lack of information, the flood began and fully loaded, and the victim ignore the information. And lastly, for the problem statement is due the specific cause. For example, in Malaysia, the flood monitoring system use a telemetry system that continuously monitor water level measurement and upload the specific web page. This procedure need internet connection to upload the value and not stable for the Malaysia due the expensive cost. Next, for the objective of this project, first of all, to measure the flooding parameters such as water level, temperature, and rainfall. Second, to design the inexpensive prototype. And lastly, to test and confirm the working of the build system. Next, for the scope of the project is focused on the accuracy in order to detect the floods and focusing on the developing hardware based on the Internet of Things. Okay, as we know, the accuracy is used to assess just how well the average measurement of multiple measurements stack up against the standard measurements of the same item or the true value, so that accuracy is the main role in this project. Literature review for the previous paper. First review is Design of Early Warning Flood Detection System and published at 2018. This purpose of the project is to detect a river's rising water level from a suitable distance from rail track or roadway and alert the authorities via SMS so they can take the appropriate action. Water level sensor will connect at different level for this project. It will be connected with microcontroller. The microcontroller will be connected to the GSM modem with a SIM card. The microcontroller coding will be stored to the mobile number of user. SMS will be sent to the register mobile once the water level reach its maximum level. Next review is implementation of an IoT-based flood alert system and the paper published at 2018. This project can also monitor the water level rising speed and alert the residents. The data from the water sensor is collected using a Raspberry Pi and sent to the GSM module, which generate an SMS warning. For the third review is the real-time WSN-based early flood detection and control monitoring system. And this paper published at 2017. The author is Tibin Matthew Dekil and Dr. N. Prabhakaran. This project is a use wireless sensor nodes to capture data image from the CMOS image sensor and transmit to a remote monitoring sensor through the ZigBee and the GSM network. Next review is the flood monitoring and early warning system using the ultrasonic sensor. The paper published at 2019. This project is using the ultrasonic sensor and the project is a focus only the water level detection and early warning system that can notify an individual in the event of the potential of the flood. The alert is sent via SMS or a website. Lastly, for the literature review for the previous paper is review paper based on IoT and the author is the Bender. This journal is published at 2017. This project is to predict the weather information such as pressure, temperature, humidity, wind speed, direction, and the rainfall. This project is use a mesh network link over ZigBee for the WSN to collect the data and Wi-Fi module to transmit the data over the internet while using a very little power. Okay, for the methodology, as we can see, this is a flowchart of the coding, and I will explain more detail about this flowchart. We begin with the temperature sensor. When the temperature sensor detect the rain, user will receive the message rain is coming. If the water flow sensor detect, it will be two conditions, low or high. If the water flow detect low, it will continue the process to the ultrasonic sensor. If the water flow sensor detect high, it will send the percentage to the user. For the water flow, the low process is set below 17, meanwhile the high process above 70. They will proceed to the ultrasonic sensor. There will be three conditions, low, medium, and high. If the water level low, it will pass to the process. If the water level medium, it will send the warning to the user. And lastly, for the high, it will send the danger to the user. Next, for the block diagram of this project, the input of the flood detection is DHT11 sensor, ultrasonic sensor, and water flow sensor, which detect all the parameters of the flood that needed to be measured. Then, the input send the parameter measure to the Arduino Uno, where the Arduino interface all the data and the export it to the output. For the output, we got the buzzer, LCD, and wireless module. All parameter data measure shown in the smartphone apps, Blink apps, which help to monitor the floods. Then, equipment for this project. First, Arduino Uno. Arduino Uno is the microcontroller of this project. Next, ESP8266. It uses a Wi-Fi microcontroller chip and has a simple programming language called LUA. The ESP8266 not MCU feature a process log and connectivity that is like Arduino. For the third hardware we use is DHT11. DHT11 is a sensor to measure the temperature and the humidity of the flood. Why we use DHT11? Because low cost power consumption, excellent load time stability, and a very low cost compared to the other sensor. Next, water flow sensor is designed to measure the rate flow water and also measure the amount of the water flow through the pipes. Then, next equipment is ultrasonic sensor. This, there is a most important sensor because to measure the water level at the tank. For the last two part of the equipment is the buzzer and the LCD. For the software, I use Arduino IDE to construct the coding and run the simulation of the circuit, and smartphone application to use to monitor the floods. As we can see here, this is the initial result of this project. This project are designed by using AutoCAD software. There are four important components at this model, which is pipe, water flow sensor, water tap, and tank. For the water tap is to control speed of the water. Meanwhile, for the tank is to storage and measure the water level. And lastly, for the water flow is to measure the speed of the water. Okay, as we can see here, this is the initial circuit simulation for this project. There are three figures as we can see here. First figure is water level low, second figure is water level medium, and the third figure is water level high. So I will show you how it works by using the Proteus. Okay, this is the initial circuit for the flood detection based on IoT. Okay, for the circuit, we have Arduino Uno, LCD, um, LED, which is have a three LED, LED green, LED yellow, and LED red, buzzer, ultrasonic sensor, and the potentiometer. So, uh, for this simulation, we assume that the potentiometer as water. So we start. When we set the potentiometer in the low, so the distance will appear 998 and the LED green is turned on. So this is the still a safe situation for the flood. And when we set the potentiometer is medium, distance is uh, 630 centimeter, and the LED yellow will turn on. For this situation, the flood is still in our warning, and when we set the potentiometer is high, the LED red will turn on and the distance will appear, which is 112 centimeters. So this is in the danger situation. Thank you. For the Gantt chart, for the first week, I do project selection and my supervisor Puan Bahira briefing me on PSM1. For the second week, I do some research background, project, and identify the problem statement and objective. For week 3 until week 7, I explore the information journal and academic paper and do some literature review. I also identify the component that used in this project. For the week 9 to 12 until week 12, I do the methodology chapter. And for the week 50, I do some improvement and modify the report. Lastly, for the conclusion is, this project is designed to measure the flooding parameter such as water level, temperature, and rainfall. Moreover, this project is a low-cost prototype. This project will be expected help to speed up the process of relocating flood settlements and reduce the flood risk. So, that's all for me for my presentation video. Thank you to my panel, Encik Asri and Dr. Karol Anwar for spending their time to watch my video project presentation. Thank you.